All right, section 9.9, representations of functions as power series. In this section, we'll learn techniques for finding a power series that represents a given function. We accomplish this by manipulating geometric series. We'll do differentiating and integrating of these series. These are useful for integrating functions that do not have elementary derivatives, solving differential equations, and approximating functions by polynomials. To represent functions on calculators and computers. That's where that's used a lot. So my power series, 1 over 1 minus x. This is equal to 1 plus x to the first plus x squared plus x cubed plus x to the fourth, so on and so on and so forth, all the way out to infinity. All right, this becomes my geometric series because we are constantly multiplying by another x. That's a geometric series. Therefore, this sum right here is my infinite sum rule. First term 1, that's your a1, over 1 minus r, r being the ratio in which I am multiplying by. So we know that this will converge as long as our ratio is less than 1 when we take its absolute value. So we're going to use the summation of n equals 0 to infinity of a being the first term. Again, I think when we talked about this before, I put in a sub 1, r to the n power, and I think in my formula I gave you was a sub 1 over 1 minus r because that represents a sub 1 as the first term. And again, this is for when r is less than 1 for its absolute value. All right, so what's actually taking place? Well, a geometric illustration for our equation, all right, back here, again, it's going to converge between -1 and 1 because it is a geometric series. So 1 over 1 minus x, that is the graph of the red curve. And we're going to look at some partial sums, and that's what these s sub 2 is. This is the sum of the first two terms. All right, so 1 plus x squared, that's going to be this curve. Of course, it's x squared because it's in the shape of a parabola. Then the next one here, s sub 5, this is the sum of s sub 0 through 5. And of course, it's x to the fifth. It's going to be a function that on the left has a left-hand behavior going to negative infinity, right hand positive infinity. S sub 8, that's x to the eighth. Again, another U-shaped curve. S sub 11 in green. But in all these curves here, you can see that they begin to overlap more and more over the red function. So I'm going to bring in my calculator here. Colors aren't going to match because I got several things typed into my calculator right now. And let's see, I'll make my calculator a little bit bigger here for you. So the first one I'm going to try to graph is the 1 over x, then the next three terms, and then y sub 8 is y sub 7, the first three terms with another 3 terms on it. Then the next 3 terms, then the next 3 terms. So let's see if I can do this real quick. I hope this works. All right, cool, got it going. So here's the 1 over x. It's going to be in gold. So by hitting enter real quick, I was able to pause it. Again, this is -1. This is +1. So let me finish making the graph. Okay, so there's that part of the graph. Now here comes 1 plus x squared. And what appears is right about here, it's now overlapping the curve. And it's probably going to overlap, to a certain point over here. So let's see if we can find that. Okay, there it is. Stop. So it overlapped right about to here. It's overlapping. In essence, it's a representation of 1 over 1 minus x as a polynomial function. All right, now here comes my blue curve. That's 1 plus x squared plus x cubed plus x to the fourth plus x to the fifth. So as this blue curve comes in, again, it's about to start overlapping the gold. So it's a better representation. We're going from here now to here. Click, click. And it stops overlapping the gold. Oh, I'm going to say right about in this area here. It's definitely starting to peel away from the gold curve. All right, let's see. Up to x to the 8th power. All right, here comes x to the 8th, the one in red. It's coming down. It's approaching the gold curve. All right, it's officially overlapping right about here, getting closer and closer to -1. And it will probably stop right about this area here. Let's check real quick. Click, click. Still overlapping. There it is. It starts to peel away right in here. And let's see, my final curve should be coming in soon. There it is. Comes up through -1, and it's all over that gold curve right here. So the more these terms are added, the more we're going to overlap the gold curve from just inside of -1 to +1. And stop. There it is right there. Starting to peel away from the gold curve at about this area. So that's what that picture represents. And again, if you wanted to, we could keep adding in more terms and we get closer and closer as you go. All right, so I'm going to put that over here. All right, example 1. Find the power series of f of x and find the interval of convergence. All right, let me back up the boat here real quick. You want to make it look like 1, or if you will, a sub 1 over 1 minus r. That's what we want this to look like. Okay, well, I need the 1 to be in front and minus the r. So the best way to do that is to factor a -1 out of the bottom, and we can then move that negative up to the top by the 3. All right, so that means a, my first term is going to be -3, my r is going to be the 2x. So now we're going to go into my summation notation. N equals 0 to infinity. We'll put in a, the first term, -3 times r, 2x, raise it to the nth power. Well, we could factor out the -3 if you wanted to, or you can just leave it like that. Either notation is fine, but that's your power series for f of x. Now, what is my IOC? Well, r being 2x, the absolute value of r is less than 1. So again, if you drop the absolute value bars, we got to go as low as -1, and 2x has to be somewhere between -1 and 1. Well, let's divide 2 to both sides. So my interval of convergence is -1/2 to 1/2. All right, example 2, finding the power series. Again, we need this to look like a over 1 minus r. So I need, wait a minute, I can't have a plus sign here. And I need the 2 to be a 1. Okay, let's see. We're going to have to divide by 2 into everybody. Every term has to be divided by 2. We need this 2 to be a 1. And at the same time, since I need a minus r, I'm going to change the plus to a minus a negative x over 2. So that means a is now 7/2, and my r is negative x over 2. Put that into our summation notation, and there's our power series. All right, so if we want to clean this up, we could factor out the 7. We can take out the -1 as to the nth power. we can factor out the 1/2 to the n. The only reason I'd want to do that is because then I can combine it with this 1/2 here, so that would be 1/2 to the n plus 1 power. So we'll take the 2 that's in the denominator, raise that to the n plus 1 power. 1 to the n, or n plus 1, will always stay 1, so we don't need that. So then here is our power series. X, negative x over 2, that's my r in absolute value bars. All right, so now my interval of convergent would be -2 to 2. So again, if you drop the absolute value bars, this becomes x over 2 because it's now positive. So we go from -1 less than x over 2 less than 1, multiply 2 to the 2 endpoints, and that's my interval of convergence. Example 3. Holy moly, we got exponents galore. Looking for the power series, so again, we need a over 1 minus r. Okay, so the first thing is we need to establish the 1. So everybody gets divided by a to the 3rd power. So x squared over a to the 3rd, 1 minus x cubed over a cubed. All right, first term, a1, or a is x squared over a cubed. R is x cubed over a cubed. Put that into our a and our r into our summation notation. And here we're definitely going to have to do some manipulating because we want to combine this r squared with what's happening over here. So I'm going to have x squared over a cubed times x to the 3n power, multiply the n to this 3, multiply the power of 3 here on the bottom, so a to the 3n on the bottom. And so this is going to change the top to x to the 3n plus 2 over a to the 3n plus 3, because we had a cubed. 3 plus 3n gives me 3n to the 3rd power. So this would be my simplified form of my power series. Where do I converge? My interval of convergence. Again, take your r, put in your absolute values less than 1, drop the absolute value bars. -1 will be less than or equal to this fraction less than 1. All right, well, we can do that, or we can say let's multiply. You'd have to do this anyhow. A to the 3rd gets multiplied to the 1, leaving it in absolute value bars. You then can take the cube root of both of those. And so now my x, again, would be a negative absolute value of a. Again, I'm going to keep the bars around absolute value of a because I don't know whether a is positive or negative to start off with. So in my interval of convergence, we don't want to put -a, comma a, because again, if a happened to be negative, we would simplify that. You'd have a positive a on the left of your interval and a negative a on the right. So we keep the absolute value bars, again, because we don't know the sign of a being a constant, could be anything. So negative absolute value of a, comma, positive absolute value of a. And that takes care of part 1.